and good morning, all of you. I'm Amol, as Rujita introduced me, and I'll be taking the second webinar in the series, which we have mentioned design transmission right first time. So you would be expecting something like this when we talk about transmission from concept perspective. We have mentioned in the previous webinar the overall procedure from concept to drawing release, what is really the right first time. And that was basically an overview of the transmission design process. Whereas in today's webinar, we'll go to some extent in depth understanding about the first aspect of any transmission, which is the concept design. So unless you have a good concept design, there is no point in going to the detailed design and finally to the drawing release. So in today's webinar, we would see the Romax concept and Romax end. So these are the two software tools which are being used very effectively in the right first time process. So we'll stick to the tagline of right first time design, even though I would be explaining the software perspective, but my context is always in line with the complete design process, right from concept to detailed design followed by drawing release. So the first phase, that is the concept design and durability analysis, we'll see in today's webinar. Now, when we talk about concept and from the context of automotive transmission, you would imagine something like this. On the right hand side of your screen, you can see there is a dual clutch transmission. Now you would imagine something like this, but at the concept stage, you want to confirm that whether your imagination would really turn into a reality or not. So from imagination to reality, conventionally, we were using various methods such as making the drawings and then prototypes and then confirming the design by some hand calculations and so on and so forth. Followed by, in the recent times, we have been using two-dimensional drawings, followed by a lot of CAE analysis, then followed by the drawing release. But there is a one of the big problem, which is that in those processes, we were not sure whether that imagination would really work or not. So we are going to address that point in today's webinar with a greater depth. And that point you should note in the beginning is that whether my imagination would work or not. So what happens when we talk about concept? This concept is a tool which is something like a sketchpad application, which is like our conventional drawing board. On the drawing board, you would draw various sizing of the transmission, including shaft, gears, and bearing, and then you would visualize your imagination in various views, whether it is 2D or 3D. At the concept stage, you would then actually look at the vehicle level parameters or transmission parameters such as sawtooth profile, because you want to ensure that whatever the speed ratios you have designed or you have imagined would work at a vehicle level or not. So followed by, you would then convert that imagination gradually into a material form by converting the shaft and gears to a packaging barred cylinders. Here you can see these are the barred cylinders fitted into a particular packaging space. Then gradually you would then start adding few features to every gears and shafts, and then start connecting the entities to each other. Then you would then convert these gears to some extent of conceptual gears, that is from barred cylinders to basic macro geometry. Here, basic macro geometry, I mean the number of teeth, module, helix angle and pressure angle, etc. Placing the bearings, placing the shafts, then placing the final drive input shaft, lay shaft, etc. reverse gear, and confirming whether this would work or not. So from imagination, you are going towards the reality. Now, what happens? Many times, we go from imagination to reality, considering the complete new design. Now, specific to the Romax tool, what we mention is that this tool not only helps from imagination to reality, but reality to imagination also. For example, if you have a transmission which works, say, for example, 180 Newton meter, and you want to confirm whether it would work for, say, 220 Newton meters of torque, you have some suspicion that it may work, may not work. And if it works, or if it doesn't work, then possibly you need to readjust the center distances. So you would convert your existing model into conceptual model and play around certain dimensional sizing parameters so that transmission will fit in the packaging space, and then you convert everything into reality again. So imagination to reality and reality to imagination. So these both things are possible in Romax concept. Here I am relating two things. One is your conceptual design in your mind or on the drawing board with the software tool which is available called as Romax concept. Now, basically, why there is a need for doing this kind of conformity tests in the beginning of the design phase itself? Because we often see when we graduate our design to a final detail level, we always come across these kind of conflicting parameters. For example, for any transmission, when we see that the transmission is finally drawings are is prototype is made, then transmission packaging costs down to year. For example, if you meet efficiency, you would sacrifice the noise. Gearbox will be noisy. If it is very nice among these vital parameters, and they are very complex with each other. How about if I manage to meet these parameters or assure you the conformity that these parameters will meet at the end? And that is all about the concept design. Now, how it works basically? In the beginning, early phase, you have broad targets. Okay. Now, these broad targets, you can look at the width of the arrow, and that width indicates the clarity about the targets. Broader the width, lesser the clarity. Now here you have some clarity about the weight, efficiency, cost, durability, and noise and vibration. Now in this case, at the concept stage, we review all the points. And design moves ahead. It starts reducing the width of the arrow. It means we are getting better clarity. Here it is the directional clarity. Here it is the moderate level clarity. And in the late phase, we confirm that our targets are meeting. We are, whatever the expectations we had in the beginning, they are achieved. Now, we need to know what are all the control points to achieve these in the beginning. That is what it means by right first time. How this will help? This will help in this way. On the x-axis, you have time. On the y-axis, you have effort and cost. For any design to materialize, you invest good amount of money and effort in the initial phase, rather than spending huge amount of time and huge amount of money in the late stage. Imagine if you have to mobilize all the resources at the end stage, it incurs a lot of money. Now, why you need then this kind of tools? Basically, when you think of any imagination and you want to visualize particular imagination, there are so many ifs and buts. There are so many ifs and buts. Something like, say, if I have A geometry, will I get X result? If I have B geometry, will I get Y result? Like that. So to confirm which one is best and which one is worth pursuing for the final design, for which Romax concept is used. Now, let's imagine you are among these one of the persona, which I am explaining now. If you are a decision maker, you want to choose the best design among given 5 options. And you want to know what is the guarantee that the chosen one will meet the performance and not give any surprise at the end. So being a decision or the manager, you want to choose one of the 5 designs. This situation often comes before a decision. Second persona is analyst. He thinks that I need an easy tool which does a quick and concurrent analysis to choose the best concept design and avoid last minute surprises. Okay. So basically he has to confirm which are the best 5 designs. Then system integrator. System integrator is basically looking for a transmission to give the necessary input data with certain confidence that other design requirements can be done without making the same model. For example, if you are into vehicle integration team, then you want your transmission team to provide you a transmission with which you should not be repeating the same exercise again and again, and you want the conformity and confidence that it meets the design requirement. In a way, if you are a system integrator, you don't have to wait till the complete transmission design is finished. Then you may be a bearing supplier also. You want a tool which quickly does the bearing sizing with good analysis so that the price quotation is robust. Many times, whether you are a bearing supplier or you are a person who select the bearing, often comes across a situation that you are not sure about the requirement of the bearing in the beginning. So if you are a bearing supplier, you would then add a lot of contingency to the bearing design. So if you have sufficient time to reduce the contingency, then that will save a lot of money and resources at your end. Now, basically what we mean at a concept stage is something like this. You are talking about the vehicle architecture, you talk about the powertrain topology, you then decide the layout, you do the bearing selection and basic gear design, etc. At the concept stage, you don't do, say, gear rating or detail levels of contact pattern analysis or any kind of noise and vibration analysis, etc. So in the concept stage, you are focusing on these things. Now, let's see, as I have mentioned in the beginning, that you have some imagination about the transmission for your vehicle. How it works? See, you have electric motor, you want to put the shafts, then gears, provide the speed ratios, provide the dimensions of the gears, put the shaft dimensions so that it will fit into the packaging space, put the boundary envelope, and then you put the complete transmission into the given packaging space. You convert the gears with certain macro geometry and then confirm that this is what you are looking for. This is the imagination you have done in the beginning, and you confirm that yes, this is what I was looking for and this is exactly it should work. Now, how it should work, at this stage itself, you should look at the durability of gears and bearings. This is the directional clarity. You would say 80% confidence that my gears and bearings would work. Then efficiency. I will confirm that whatever the mechanical efficiency I want, it is near about that. Followed by NVH, followed by packaging, weight, cost, and full system, and all other key components. Then at the same time, you would interface with other CAD packages so that your concept is transferred to them so that they can work on their independent tool chain. Then you would convert your model into multi-body dynamics format so that they can do vehicle level analysis. And so on. There are plenty of other packages where you want to transfer the data in the concept stage so that they can work independently. Here, what I mean is that they don't have to wait till you finish your complete transmission design. By way, you can save a lot of time. Basically, how it works, system integrator. System integrator would confirm once you give him a design, then he would look at your design, he would look at the sawtooth profile, he would get the multi-body dynamics format of the transmission, and then he would confirm that this gives the better fuel efficiency and better carbon footprint. So at the concept stage itself, you are confirming that it will meet the Euro 5 or BS6 norms or any of the emission norms, etc., so that you can avoid the last minute surprises. Here itself, you can tell your concept designer that this doesn't meet the required criteria, you kindly change certain parameters. This is one such example as how Romax concept helps at a system level. Now let's look at ifs and buts kind of situation. You have, say, so many options of design. Say your manager asks you that, okay, you have some imagination, and how many designs you would imagine? You would say something like, say, I would imagine maybe few hundred. It all depends on your imagination power. And here what I mean is that this is all different macro geometries or different bearing selection criteria, different shaft dimensions, etc. Now, which one I should choose? So what I will do is, first I will eliminate the designs which doesn't meet the cost. Second, I will eliminate the design which doesn't meet the efficiency. Third one, I will eliminate NVH. Fourth is the durability. Then I'm left with two designs. Few imaginations, I know they will work. Now, among these few imagination, which would work? So let's see. Somebody may say, okay, choose any one of them, but that is not again the right way of doing it. So basically what you should do is, here you should see that if I choose particular design, what is the guarantee that when we go for any smaller modifications or optimization at the end, once the prototype is built, then it should have sufficient design space. Now, for example, here what I mean is, if you select a design, say design A, and if it happens, you have to optimize the microgeometry, that is the lead end profile of the gear. And you have chosen design A, and you would find that design A microgeometry optimization has a really smaller optimization space. At that time, you would feel that, oh, I should have used design B. Why I should have chosen A? Now, this is exactly where this tool helps. Now, in this case, let's see, you have efficiency parameter, and the design which you have chosen, let's say rationalize that design, and let us see that the efficiency which you have optimized, which you have arrived is 1. And design A, when you manufacture, because of the manufacturing variation, efficiency deviates in negative direction by a certain percentage. Okay, so here it is, say, let us make it set 100% efficiency. What I mean 100% is that at the concept stage, design A has got, say, 90% efficiency. I'm rationalizing 90% to value of 1. Then, if you go left side or right side or top side or bottom side, when you are in your tolerance band, then you would lose certain efficiency with respect to 1. So this is about the design A. Now, if I would have chosen design B, then I would have had larger optimization space. With the manufacturing variation, it should not have lost the efficiency. This is how it will help. So if you are a manager or if you are an analyst and your boss says you have 5 designs in your hand, show me a concrete and scientific evidence that A is better than B or B is better than C. So this is what it should be. Now, as I mentioned, I will re-summarize so that you can relate the previous slides, and the story we are talking about is that to visualize the imagination for ifs and buts situation. Okay. Now, how this Romax concept works, you can see on the x-axis, you want to do durability, efficiency, NVH, bearings, and electric machine. And these are the 6 packages. So in the context of design, we are talking about Romax concept. This is the package. If you want to do the complete durability in depth on the y-axis, it is the level of details and depth. Then you should use Enduro. But since you want to confirm at the concept stage itself, Romax concept do pretty much everything across all the requirements in the beginning phase. So for spins, for spectrum, that is for MVH, for efficiency, it does a lot of things. Now let us come to the Enduro. So we are moving from Romax concept to Enduro. In the enduro, we often face a common problem is that you made a design and you say, oh, I took every care, but the gearbox has failed. How? Then you said, I want to design the transmission, but will gears survive? You do not know what is the scientific way to confirm the gear design. Although people do a lot of hand calculations, but what is really the hitch point? That is what we are going to see in Romax Enduro. Then you say, I have done a gear sizing by hand calculation, and now gear seems perfect. Okay. You say, I selected the bearing as per supplier recommendation, but the gears and bearings failed prematurely. Now, why is gear failed prematurely? You said you have taken the bearing supplier's recommendation, you have gear sizing done with hand calculation, you were pretty much sure that it will work, but still the gearbox failed prematurely. Why? It's because there is a problem in the loading condition. There's a problem in the loading condition. Why that loading condition problem occurs? Again, you would imagine yourself in this scenario. You say, I have designed the gearbox, but do not know whether it will run for intended design life or not. For example, you would say, I want my vehicle to run, say 3 lakh kilometers, 300,000 kilometers. I do not know whether the gearbox will run equal kilometers of life or not. You say, okay, I have a road load data, but do not know what is the scientific way to make a duty cycle. Because this road load data has a billion data points and you cannot work on these billion data points. So you do not know what is the scientific way to do it. So how you will confirm that whether it will run for intended design life? Obviously not. So then you say, okay, even after converting the road load data using say rain flow analysis, gearbox failed prematurely. So what went wrong? So you want to confirm that. You go to the test. Okay. Now you say, okay, if it works on the test, it is going to be the same. But in the testing again, there is a problem. And you say that I have tested the gearbox on test week for 800 hours. But I'm not sure if these 800 hours are true representation of whole road load data or not. So how do I ensure it? So basically we need to see what went wrong. So we said, okay, module, number of teeth, pressure angle, face width, and we calculated the contact and bending stress. But this is the sizing. Sizing is not given and it does not validate the design. You need something like this: torque, RPM, and duration. And this road load data doesn't mean that it is representing the true road load data. So you have to ensure that you need this type of duty cycle, but at the same time, this should represent the true road load data. And you should do the design and validation at the system level. So what is meant by system level? How does it help? How does it overcome from basic sizing? In the Romax Enduro, which is the in-depth analysis for the durability, what you do is you completely model the system. Here you can see I have given the example of electric motor driving the gear systems. here you can put all the details of the gears, or say from Romax concept, you have converted this model into durability. You do the structural analysis, you do the durability analysis with various standards such as AGMA, ISO, and DIN. You calculate gear safety factors, you calculate bearing life, you calculate shaft fatigue, you calculate spline safety, etc. Then you do the reporting. This is what the logical sequence once you qualify from your concept going to the detail. So this will ensure everything at a system level, and it will ensure that the gearbox will not fail prematurely. So when I have mentioned that everything you should do is at a system level, what does it mean? It means you have gears, they are mounted on the shaft. What you have done is you have done the gear analysis in an isolated condition. You were not considering these shaft deflections, because of which the load on the bearings were varying. You just considered the constant bearing stiffness, which was wrong. But in Romax Enduro, it considers everything together under the dynamic condition. And there were other axial loads, circlips or clearances, etc., or rise in temperature and other conditions that you have not considered. So considering all these things, such as again, which is the flexibility of the housing, you then make the gear design, which is the perfect way of doing the gear design. And then finally optimizing the gear parameter. You may say, okay, I would do all these things, but at the same time, I should work with other softwares also. What is that? If I have to change certain vehicle level parameters, or I have to change certain parameters in the gear system itself, then this Romax Enduro ensures you that it is at the heart of ecosystem. So it speaks with other packages seamlessly. So such as ANSYS, Abacus, Mastron, Altair, etc., and other bearing manufacturers, other optimization softwares, then other manufacturing softwares such as Gleason or Klingenberg. Okay, and with other CAD packages such as CATIA or ProE. So basically, in a way, it is the trusted industry standard solution for electromechanical powertrain durability, and this has now become a world standard. It is the global standard. Whenever people want to use the gear system analysis, they would use this software. Then this is fast, accurate, and analysis which gives the basic, very in-depth insight and optimization. So basically, you are looking for the fast and accurate system. There is no point in the system which would take days to analysis. You would want it in a couple of hours. That's it. Then full system structural analysis, not the gear in isolation. This is what it does. Then it is at the heart of ecosystem where you can communicate with other CAE-led design softwares. So in a brief summary, this is all about the Romax concept and the Romax Enduro. I thank you for watching this webinar.